Hey, welcome everybody to video number 18 in the UE5 vehicle tutorial series. In this video we'll be implementing a 2D gauge cluster for the player UI. Now in a previous video I've shown you how to make a 3D widget, but a lot of people don't like that and want to go the traditional route with just a texture basically. And we're going to need two things for that. First of all would be a texture for the gauge cluster itself, just a background texture. As you can see here, it's got no needles for the RPM and speed because we're going to animate those, and so we had to import the needles separately. And the needle looks something like this. If I just toggle all of the channels except for the alpha, now it's a square texture, and the pivot point will be placed in the perfect center of it inside of the material so we can rotate the needle. And so it's important to have kind of the knob here perfectly centered onto your texture. Now if you don't have those, because you're not like a UI designer, you can Google textures like that, just like I did, and you'll find plenty of good textures you can use, or you can just subscribe to my Patreon and download the project that I'm using for these video tutorials. So I've already imported those. First thing you want to do, well actually the only thing you want to do in the needle texture is you want to go here in the settings . I can't seem to, okay, texture advanced. Yep, okay, so in the texture advanced you have the X and Y axis styling method. You want to set those to clamp, because we'll be using a texture coordinate node in the material to make them smaller or bigger to match the size of the gauge cluster. And if you leave that by default, it's gonna tile the texture instead of just resizing it. That's all you have to do for the needle texture. Again, just you can basically open up Paint and just draw a line if you want, so you'll be able to follow the tutorial. And if you've watched video, I believe it was 16. Let me pull it up. Yeah, 15 and 16 we did a little music player. So we'll be using the same widget and just adding the gauge cluster onto it. But you can create a new widget if you haven't followed those tutorials. Very first thing, we will create a new material. Call it m_gauge cluster. Open that material. Right away, go here into the shading model and select, that would be, sorry, material domain instead of surface. We're going to go user interface. And in the blend mode, we'll select translucent to expose that opacity node here. Then we can just drag our textures in. First one would be the gauge cluster. You can see the little preview here. And right away, let's open up the widget and add that to it so we can test it often and see what it's gonna look like. My computer is so slow at compiling shaders, even something as simple as this. Alright, now if you follow tutorial 15 and 16, we have here the UMG music player. We're actually going to rename that because it's not just going to be the music player anymore. call it UMG player UI. You can open that up. Sorry about that. Let's add an image to it. Select here our newly created material. Now the size of the texture here for the gauge cluster is 1024 by 1024. Size to content. Let's go ahead and anchor it to the bottom center. Set the alignment here to 0.5 and 1. As you can see here, that should probably be smaller. Text size here, how about 24 or even 20? Alright, cool. Let's jump into the game here and see what that's gonna look like. Okay, I like that. And with that done, we can go back into the material and add our needles. Just drag and drop it. Now there's two things we have to do. Well, actually many things. I don't know why I said that. We'll start with adding a lerp. Linear interpolate. And we'll use the alpha of the needle into the lerp for the final color. And the opacity, just for now, we'll unplug it so now we can see the needle appear here. It's way too big. So we'll add a texture coordinate. And what you can do with the texture coordinate is you can set the tiling here. Now I've done this before off camera, so I know exactly all the values I need to input. Of course that's going to be different for you with the texture you're using. So I'll set it to 3.5 here, because I know that's roughly the right size. Now you can see it's not located properly at all. So we'll use an add node. Then we will add a constant to vector. And we can set that you can see the needle moving here as I'm changing the values. Now again, I know for my exact use case that will be minus 1.85. Oh, that's right. I need to add a custom rotator. Add another one of those, vector 2, for the rotation center. We'll set that one to 0.5 and 0.5. So again, that's setting the pivot point for that texture perfectly in the center. Now you can see here my needle is positioned properly. So again, you can change those. See how the needle is moving. So you're gonna have to adjust those until the needles are in the right place, like so. And for the rotation, we're just going to create a scalar parameter. And that one is the speed needle, so we'll call it speed range. Now that scalar parameter we can edit inside of a blueprint by creating a dynamic material instance, and we want that to be a value of 0 to 1. We'll use a lerp again, linear interpolate, plug that into the alpha, plug that into the rotation angle. As you can see here, rotation angle is either 0 or 1. And we're basically just going to put whatever value we want here. So at 0, the A pin is going to be used. So we can set here. Let's go ahead and set 0.1. You can see it's not quite low enough. So 0.05. Oh, that's actually even higher. 0.15. Okay, that's good. Now if we set the range to 1, we can adjust the end position. Now that one is going to have to be negative since we go further to the right as we decrease. Alright, so now we have a needle that rotates. I don't know how well you can see that on camera. I should probably make that bigger. There you go. Now you can see we have a needle that's going to rotate as we change that float variable here. And we'll do the exact same thing for the RPM needle here. Just go ahead and copy and paste that. We will be adding another lerp. So again, copy and paste. Plug the output here into A, the output in the final color. In B, again, use the output of that one and the alpha of this one. Now both of them are on top of each other, that's why you're not seeing any difference. Let's remove that scalar parameter, we'll create another one. And already you can see the needle changed angle. Now the position for that one, in my case, again those values won't be good for you unless you use the same textures as me. Okay. And we just need another scalar parameter. This one we're going to call RPM range. And we'll set, pretty sure the lerp are going to be the same from 0 to 1. Yep, exact same angles here for the rotators. And all what we need to do is take care of the opacity. And the way we're going to do that is we're just going to add them together using the plus here. Copy and paste. Plug that into the opacity. And just add all three opacities to each other. And then be sure to use a clamp here, because the opacity should be anywhere from 0 to 1. We don't want to end up with an opacity of 2 where the needle is over the gauge, because that would be pretty bad. So that concludes it for the material. If we go back here into our UMG, you can see the needles here. And now onto the blueprint part of it. You're going to go here, actually, first of all, select the image, make sure is variable is checked so you can reference it in your blueprint. name it something that makes sense. Okay, so we already have the event construct here. Completed. Actually, we'll ignore all of that and just create a sequence. And we will, like I said earlier, create a dynamic material instance. We'll use our gauge cluster material. We're going to create a variable to hold the result of that by using the promote to variable. I'm going to call that something like gauge mat so we can use it later. Now we want to grab our image, gauge cluster image here, and set brush from material. Set brush from material right here. To instead of just having the material that we've selected in the content browser, we want to be using the dynamic material instance that we just created. Okay. Now you're not going to see any changes right away. So what we need to do, we'll be using the event tick, although I always say not to do that. Because if we don't, the movement of the needles is going to be jittery and it's not going to look good. Now I see here I do not have a reference to the vehicle that the player is driving. So let me go ahead, before that sequence, let's get the owning pawn. Get owning player pawn. We'll cast it to our parent vehicle, which in our case is the Porsche. And we're just gonna return a print string just to make sure that cast isn't failing. Let's go ahead and test that right away. And we're getting a hello, so cast successful. We will again grab that cast, promote it to a variable, which we're going to call player vehicle. Now into the event tick, we're going to grab that player vehicle, get RPM. Now if you follow those tutorial, you're going to have those float variables. Otherwise, from the vehicle pawn, you want to get the sorry, I haven't touched the project in a little bit. Let me reopen our vehicle masterclass here. Because I recall creating a variable, movement component variable, I'll be using that to get the RPM. There you go. Get engine rotation speed. Now that's your RPM. Let's get here our gauge mat. Sets counter parameter value. Now the parameter name here, if you go back into your material, for the RPM is RPM range. We're going to use a map range here to convert that RPM into a value of 0 to 1. So from 0 to 6,000, because my texture only goes up to 6,000, we'll output a value of 0 to 1, and we can use that right here. So let's test that again. Now this is working. All we need to do is the speed, which is going to be the same principle here. So copy and paste that. Change the name here, the parameter, to speed range. Get forward speed here will give you a value in kilometer per hour. Get forward speed mile per hour does as its name says. Now the gauge cluster texture I have, it's written kilometer per hour on it, so I'll be using the kilometer per hour speed. Again, you need another map range. Always use the map range clamped. So again, from 0 to 1, speed on the texture here goes from 20 to 220. So I guess I'll be a minimum 20 to 220, sorry. And I think I'll do the same for the RPM here. RPM starts at 1,000. So I'll be using 1,000 here for the minimum. And now we can test that again and see that I forgot to plug the target. That should work much better. Okay, I think something is wrong. Let's go ahead and add a print string. Oh, get forward speed here. Could it be like in centimeter per second instead of kilometer per hour? That could be it. Now if you've watched any of my tutorials, you know I like to set up my print string like that. Give them a duration that's not 0. Give it a visible color. And by choosing a name for the key, it'll override itself instead of creating a list of print string. Yeah, okay, that is definitely centimeters per second. which means we have to multiply that. Thank you very much, Google. We have to multiply that by 0.036. And that's it. It's as simple as that. Well, simple. Not really, but once you've done it a couple times. And so if you wanted to add more needles, for example for a boost gauge, or to actually make those fuel and temperature needles functional, it would be the exact same thing. You would just need to copy and paste that, just add another lerp and another add node, create a new scalar parameter, and just remove the texture for the needle here so you can place it like that. And yeah, there you got it. Traditional 2D gauge cluster for your race car. Hopefully that was useful. Thank you very much for watching. As per usual, you can look in the video description for the link to the Discord server and also to my Patreon page, to which you can subscribe to gain access to this project. So on that note, I will see you next time.